Okay, welcome back. What I want to look at is powers of tens, and this is understanding mathematical principles which are appropriate to electrical installation, maintenance, and design work. Now, by the end of this outcome, you will have had the opportunity to identify and apply appropriate mathematical principles which are relevant to electrical technical work tasks. Now, whatever level of engineering that you are studying at, there is a need for some knowledge of mathematics. Okay, it is relevant, you cannot get away from it. Mathematics need not, with practice, be as daunting as you think. Now, you get better at maths when you do the relevant practice. So the key word here is practice, practice, practice. Okay? Now, most maths is a way of writing a long, complicated process down on paper using symbols instead of words. Two BMW cars plus a Subaru and a Range Rover equals 4 vehicles. If you know the meaning of the symbols and the order to use them, you are halfway there. 2 plus 1 plus 1 equals 4. And again here, I've just done a simple recap session in regards to most of mathematics is a way of writing a long, complicated process. Okay. Now, common symbols used in engineering mathematics. The symbols are easy to write and are recognized by everyone. Symbols add, subtract, multiply, divide, equals, is not equal to, is approximately equal to, is less than or equal to, is greater than or equal to. Okay. And here you have your symbols, more symbols, brackets. Do this first. Now, in BIDMAS, it'll be brackets or BODMAS, whichever one you may be familiar with. It simply states that brackets should be done first, okay, before anything else. Okay. Plus or minus, often used in answers, infinity, right angle, and this indicates an angle. Okay. Now, in the electrical industry, you could be working with electricity, which is measured in amounts such as 60 million watts. This is a very large number. Also, you could be measuring capacitance, which uses very small values such as 10 to the minus 12 microfarads. Now, if you look at this, there's 3, 6, 9, 10, 11. It'll be 10 to the minus 12 in this case. Okay. Now we have what we call microfarads, nanofarads, and picofarads. Those are the values given in regards to capacitance values. Okay, but remember that these are very large values. So we use 10 to the minus 6, 10 to the minus 9, and 10 to the minus 12, which gives us measurable values that we can actually use in the value of our capacitors, okay, in regards to farads. To make these numbers usable and to reduce the possibility of mistakes, we need to make sense of these numbers. This is done by breaking the numbers down and using symbols. So here we have powers of 10. 1 times 10 to the 12, you can see here is a very large number. 1 times 10 to the 9, 1 times 10 to the 6, 1 times 10 to the 3, 1 times 10 to the 2, which will be 100. 1 times 10 to the 1 will simply be 10. Now 1 times 10 to the 0 is 1. Anything raised to the power of 0 is 1. Unity. 1 times 10 to the minus 1, 1 times 10 to the minus 2, and that's what we're looking at here. These are representative of the values. That means then that becomes centi. Here 0.1 to the minus 1 is deci, okay? Okay. And here they're simply saying here that this would be used with the decibel, okay? Make sure I can get everything in, okay? I believe I can. Okay, yes, okay. Now 1 times 10 to the minus 3, and here that will be milli, okay? 0.01. 1 times 10 to the minus 6, and here you have it 1, 2, 3, 4, 5, 6. Okay, simply the amount of decimal places which has been moved, and that's micro. Okay, 1 times 10 to the minus 9, and that is nano, and 1 times 10 to the minus 12, and that is pico. Pico. Okay, now it's not the name of a banana or a fruit, it's the name given to the size and value of a given capacitance. Now prefixes and symbols. To make life easier, when working with very large or very small numbers, we use prefixes, which are a symbol to show the value of the number used. Engineers use numbers which are multiples of 1000. K is the symbol or prefix for 1000. Okay, the symbol K is short for kilo, which is 1000 of anything. The easy way to write 1000 volts is 1K. Okay. Now 5 kilograms is 5,000 grams. 1 megawatt is 1 million watts. Okay, and we're here. Okay. Now here we have something called standard form, and another way to solve the problem of very large or very small numbers is to use standard form. In standard form we use powers. A power is the number of times a number is multiplied or divided by 10. Okay? And here you have values. 10 equals 10 to the 1, 100 equals 10 times 10, or just 10 squared. 1000 equals 10 times 10 times 10, or 10 to the cube. 1 equals 10 to the 0. 0.1 equals 10 to the minus 1. which is 1 divided by 10, which is 0.1, and 0.01 equals 10 to the minus 2, which is 1 again divided by 100, and 0.01 equals 10 to the minus 3, or if you like 1 divided by 1,000. Okay. Now standard form, again, any number can now be written in standard form. Standard form numbers must be between 1 and 10, and any adjustments are made by multiplying by a power of 10. So 4,800 equals 4.8 times 10 times 10 times 10 equals 4.8 times 10 to the 3 equals 4.8 kilo, 4.8 thousand. Okay. Now the index of power corresponds to how many places we need. So we have moved the decimal point. Here, m times 10 to any number, m equals any number, n equals any power. Okay, now that's all we're saying here. Okay. If the decimal point is moved to the right, then we have a negative power. If the decimal point moves to the left, we have a positive power. Okay. And all I've done here again is to recap that, just made it bigger to be more visible. Okay. And again, just expanded this a little bit more as well. Now, practice on calculating standard form. So here, write the following numbers in standard form. So do this first, try this first before you go on to look at the answers. Okay. And this is what it will look like in our answers. 3.891 times 10 to the 3, 3.764 times 10 to the minus 3, and 2.4578 times 10 to the 4, 3.795 times 10 to the 2, 4.6 times 10 to the minus 3, and 4.5 times 10 to the minus 2. Okay. Now in engineering form, which is what electricians generally use, we use prefix instead of powers. So instead of expressing 48,000 as 4.8 times 10 to the 4, which would be the case for standard form, we use a recognized prefix of kilo, which represents 1,000. 48k, 48,000, instead of writing 48 times 10 to the 3. Okay. By moving the decimal point in thousands or 3 spaces to the left or to the right, the following would be 5.837 grams equals 5.837 times 10 to the 3, 5.837 kilograms. 0.0415 grams equals 4.15 times 10 to the minus 3 milligrams. Now be aware of that, keep that in mind. 39,400 grams equals 39.4 times 10 to the 3 kilograms. And again, I've just expanded this here larger for you so you can see it at your own recap session. Okay. And again, with each of the examples shown, convert the number expressed to its whole number. Okay. So again here, you will do this for yourselves. Okay. And here are your answers. Okay, it will not 400,000 volts, 0.24 amps, it's okay, I'm just making sure that I have this in the right frame. $240 milliamps, that was part of 1,000, so it's 0.24 amps, 10 to the minus 3. Okay. 22 kilowatts will be 22 times 10 to the 3, 22,000 watts. Now bear in mind that, sorry about that, I just hit the keyboard. Okay. So bear in mind that we use kilowatts because watts is quite a large unit in itself. Okay. So 340 millimeters will be equal to 0.34 meters. Okay. Simply divide that by 1,000. 220 microohms equal to 120 times 10 to the minus 6, and here you will have that. Okay. Now, operators, now each prefix or letter what has a meaning. It is important to become familiar with these. Okay. So again, you will fill in. Let's go back a little bit. You'll fill in this box of your own accord before you proceed. Now, you cannot write on the screen, so please write out the table in your own writing pad. Then see what the answers are. Okay. Okay.